Hello all, welcome you all to my lecture. I'm Abdul Basit. I'm an assistant professor in the Department of Information Technology at Haji Kartra Uttar Houdia College. Today I will be presenting on the topic of digital image processing. Introduction to digital image processing. Here I will provide a definition of a digital image processing or DIP as a field that involves the manipulation and analysis of digital images using computer algorithms and software. I will mention its wide range of applications such as in medical imaging, remote sensing, and photo editing. I will conclude by saying that the presentation will explore the fundamental concepts and techniques of digital image processing. Fundamentals of digital images. In these slides covers the core components of a digital image. I will define pixels as the smallest individual elements that make up an image, which each representing a specific color or grayscale value. Resolution. Resolution is the number of pixels in an image, typically expressed as width and height. I'll note that higher resolution images have more detail. Bit depth is the number of bits used to represent the values of each pixel. I'll explain that a higher bit depth can capture a wider range of colors. Image acquisition and representation. This slide explains how images are captured and stored, like image acquisition, image representation, and file format. In this, image acquisition is the process of capturing an image using a sensor like a digital camera or scanner. This sensor converts lights into a digital representation. Image representation refers to how digital images are stored as a 2D array of pixels with a numerical value for each pixel's intensity. This allows for efficient processing and analysis. I'll briefly mention file format like JPEG, PNG, and TIFF, notifying the differences in compression, quality, and metadata storage. Next one is the image enhancement techniques. After capture the image, in this slide I will describe techniques to improve image quality like contrast adjustment, histogram equalization, noise reduction. In this contrast adjustment enhances the differences between light and dark areas to improve visibility. In histogram equalization, redistributes pixel values to improve contrast and detail. In this noise reduction, involves applying filters to remove unwanted artifacts like grain while preserving important details. Next is the image transformation and segmentation. This covers how images can be changed and broken down into parts like spatial domain transformations, frequency domain transformations, and image segmentation. These spatial domain transformations are operations applied directly to pixel values like sharpening or blurring. In frequency domain transformations are performed on the Fourier transform of the image for thinking like noise reduction and enhancement. In image segmentation is the process of partitioning an image into a meaningful regions or objects for further analysis. In this, image segmentation techniques includes thresholding and edge detection. Next one is a morphological image processing. This slide will discuss morphological operations which are based on shape. After the segmentation or a frequency domain or a spatial domain, we work on the overall image like shape, like dilation, erosion, opening, and closing. Dilation expands object boundaries to fill small holes or connect regions. Erosion shrinks object boundaries to remove small detail or separate regions. Opening is an erosion followed by a dilation, used to remove small detail while keeping the main shape. Closing is a dilation followed by an erosion, used to fill in small holes and smooth boundaries. Next slide is the image compression and color processing. It covers how images are compressed and how colors are handled. Image compression, through this image compression, color models, and color image processing, like color image compression to reduce file size for efficient storage and transmission, either losslessly png or with some lossy of quality compressions. So losslessly compression is png. It does not reduce the quality of image, and lossy compression is reduce the quality of the image. In the color modules are different representations of colors like RGB, HSV, and CMYK that allow for efficient processing of color information. So color image processing includes techniques for enhancing, correcting, or modifying colors. So next one is applications of digital image processing. I will provide real world examples of digital image processing like medical imaging, remote sensing, computer vision. In this medical imaging, digital image processing enhances and analyzes medical scans like X-ray and MRIs to aid in diagnosis. In remote sensing, it's used to process satellite and aerial imagery for environmental monitoring and disaster response. In computer vision, digital image processing algorithms are essential for tasks like object detection and image recognition, helping mechanics interpret visual information. So next, future of digital image processing. I will conclude by looking at future trend like AI and machine learning, real-time processing, and multimodal imaging. In AI and machine learning are enabling more advanced tasks like image classification and scene understanding. In real-time processing is becoming possible, enabling applications like video analysis and augmented reality. Multimodal images involves combining different types of data like visible light and infrared for comprehensive analysis. Thank you. Thank you all.